Hello and welcome back to Sci-Fi Tech. In this video, I'm going to show you how to make this very relaxing accidental piece of art with using an RGB LED and an Attiny85 microcontroller circuit. Stay to the end of the video where I tell a funny story of how I made this piece of art. Let's get started. And these are the items that you're going to need to make for this project. The items you're going to need is an RGB LED common cathode, an Attiny85 microcontroller, an 8-pin IC socket holder, a push-button lock switch, a Perfboard, a 3-volt button cell battery, a 3-volt button cell battery holder, and you're also going to need some wire. Now let's go ahead and assemble this project, and let's get started. I have right here this RGB LED, and when I light it up, it makes this focus point of light. This focus point of light isn't good for this project because it will focus the light in the center of the cube. I need the LED light to disperse more evenly so it lights up the whole entire cube. And to do that, I'm going to take these clippers and cut off the tip of the LED. Doing that will remove the lens on the end of the LED and will allow the LED light to disperse more evenly. Having a flat top will cause more light to spread out. Having a curved top will cause a focused lens effect, which will cause the LED light to be more concentrated. And there, it should look just like this. A very important note to know is if you cut the LED tip too low, it won't work. So you need to cut the tip a little bit closer to the top. Cut it again. Cut off the sides so it's a little bit more flat and smooth. And now let's test it out again. And as you can see, it now works. Perfect. Now looking at the LED light's now more dispersed compared to a non-cut LED, and you can see the LED light's more focused. Next, I'm going to 3D print the housing, and while it's printing, I'm going to create the circuit. First, I'm going to take the 8-pin IC socket holder and place it onto the perf board, just like this. Clamp it down. Solder in the first pin. Remove the clamp. Press down on the IC socket holder and remelt the solder so that way it can be flush with the board. As you can see, not very even, so I need to repeat the same process on the opposite side. There we go, the IC socket holder is now flush with the board. Perfect. Now solder in the rest of the pins. Next, I want to take the RGB LED and I want to connect all of the anodes to pin 5, 6, and 7 and connect the cathode to pin 4. I'm going to take the cathode, put it in this corner so it's separate from the anodes, and then place the anodes into place, just like this. Don't push the LED all the way through because I want the LED light to disperse much evenly inside the cube. And now, solder it into place. Next, I'm going to take the first anode and place it onto pin 5. Cut off the excess. Solder bridge it to pin 5. And now take the third anode and place it over to pin 7. Cut off the excess. And now solder bridge it to pin 7. And now take the second anode and place it over to pin 6. Carefully cut off the excess and carefully solder bridge it into place. Put a very light amount of solder so you don't cross bridges. Next, I'm going to bend the cathode lead in this direction and then carefully bend it into an angle. Solder tin it, and now take a bridge wire and solder it to the tip, and then solder the bridge wire to the pin 4. And now solder the bridge wire to the tip, and now bend over the bridge wire to pin 4, and then solder it to pin 4. Take 2 jumper wires and the 3-volt button cell battery. Take 1 jumper wire, connect it to pin 4, which will be negative, and connect it to the negative of the 3-volt button cell battery. Another jumper wire to the positive of the 3-volt button cell battery, and then touch that jumper cable to all of the anodes. And as you can see, the red works, but it looks a little bit yellow. Ah, that's because it's connected to green. Alright, so I need to make sure those are separated, but the blue works, that's good. The red and green are now connected, so I need to separate those two by remelting the solder. This is exactly why I said be careful when you put the solder, don't put a heavy amount. Putting a heavy amount will cause the 2 bridges to connect together. As you can see, I placed too much solder, so I need to remove some of the solder. Remelt it, reposition that anode, clamp it down, and there. Now I'm going to lightly put some solder onto the pin 5. And then repeat the test. Red works. Green works, good. And then blue still works, perfect. All of the pins are now separated and everything works. Next, I'm going to place the push button lock switch over to pin 8. Bend over the leads. And bend that lead over to pin 8. And now solder it into place. Remelt the solder so it's flush with the board. And now solder bridge it to pin 8. Next, I'm going to take the 3-volt button cell battery holder. This side's positive, this side's negative, and I want to connect the positive over to the push button lock switch. Place it in just like this. Solder it into place. And then solder in the positive pin, and then solder bridge it to the push button lock switch. And there, the positive is now soldered to the push button lock switch. Next, I'm going to take this negative wire, solder it over to pin 4, and then solder the wire over to the negative terminal of the 3-volt button cell battery holder. Connect it to the negative, just like this, and then connect it to pin 4, just like this. And now, take the Attiny85 microcontroller and place it into the IC socket holder. And now connect the 3-volt button cell battery. And there, the circuit is now complete. Now, let's go test it out. And there, it works. And down in the description below, I have the code to the Attiny85 microcontroller, so then that way you can make the RGB LED glow like this. And the other items that you're going to need is a flower pot, and this piece of plastic. Now, a funny thing is, this piece of plastic I actually picked up about maybe a few years ago, where I used to work in a kitchen, and one of my team members, we were at a food station, and we had, this is actually a plastic lid, and this plastic lid was on top of the food station, covering one of the foods that we cut up for preparation for making sandwiches or other types of food. And the funny thing is, there was actually a deep fryer right next to the station. One of my friends did something, I don't know how they did it, but they did something where they actually bumped the lid off, and then the lid fell inside of the deep fryer, and then it caused this to happen in the deep fryer. So the lid actually melted from the heat of the oil and started to bubble up from the water that was on this and whatever was in the plastic to cause it to bubble. So my friends freaked out, and I went over with a spatula and picked it up, or tongs and picked it up and took it out, and then I just placed it on the counter to let it cool. And I looked at it and I thought, oh, that is so cool. And so I took it home, washed it, and then I actually decided to use it for this project, which is actually very cool. So yeah, I'm going to go ahead and take this and this and combine it together. Next, take the flower pot and this fried piece of plastic. Pick a certain corner, and I choose this corner. Place it into the pot like this. And from the way it looks, I like this angle. Placing this piece of plastic in this angle will allow the LED light to disperse evenly into the plastic. Next, I'm going to make a few tests where I'm going to turn off the light, take my circuit, turn it on, and place it inside the pot. And then take the fried plastic and place it in, so that way I can figure out the angle of how the LED light's going to disperse evenly in it. So far, this corner looks good. This one's alright. This angle looks very good. I think I'll go for this angle. Or actually, this one. Yeah, this one looks a lot better. So now what I need to do is figure out the angle so the LED light can shine on it the best. Hold it in the angle that I want and hot glue it into place. And as an added bonus, the hot glue itself will allow the LED light to disperse evenly. And there you have it, the project is now complete. As you can see, it's nice and strong, holding into place. The LED light inside is shining, and I can easily turn it on and off, just like this. And as you can see, it glows very nicely. It covers the entire piece of plastic, making the whole thing glow. Now let's see how this looks in the complete darkness. As you can see, it looks very mesmerizing, glowing completely like expected. This looks very nice. And there you have it. Now you know how to make your very own relaxing accidental piece of art with using an RGB LED and an Attiny85 microcontroller circuit. Thank you for watching SciTi Tech. I hope you learned something new, and don't forget to like and subscribe, and of course click on the bell icon to be notified for future SciTi Tech videos. Till the next tech, goodbye.